Okay, so my name is Hari Seshadri. We're going to talk about career opportunities in system on a chip design. So I'll show you the agenda soon. I'm happy to welcome my elite list of panelists. We're about 10 of the people are going to the veterans in industry are going to join this call and help you answer your questions. So keep typing your questions in the Q&A section. We'll answer after we cover the presentation, right? So expect the presentation to go about 45 minutes or so. So we'll give enough time to ask all your questions in the Q&A window. And yeah, some of you prefer to talk. Yeah, please put in the Q&A session. You will mute and get you on the panel, then you'll be able to speak if required. If you think you want to talk, elaborate, we can do that also. Just keep typing. So we'll after the presentation, we'll go back and look at the Q&A. Okay. Okay. So I want to condole the death of Dr. Gordon Moore. He died a couple of days before. This is a sad day for all of us. He is a trendsetter, right? I think we're going to talk about some of the attributes for a great engineer, how we can differentiate and these things like that. So Gordon Moore is a real example we can look for. If we all know what is the Moore's law, we all know that, so I don't want to talk about what is Moore's law. That's still holding good today, even in 2023, right? So you would have invented it many years before. So it's still holding good, right? So hats off to him, Dr. Moore, and so on to his, his innovation, invention, everything. So he's really shown us the path and like how to work and things like that, right? So let's pray for the soul to rest in peace. Okay, so this agenda. So we're going to do a bunch of things. First, initially, we are going to look at what are the needs. We'll see what is the system, right? Typically, I'll tell about. So what we'll define what is system. We'll see some examples for system. Then we'll go to system on a chip, right? Because then we don't know what is the system. Then how do we understand system on a chip, right? Somebody has raised a hand. Hello, can you look at chat windows? Any questions? One of the students needs that.
Okay, sir.
Ravi Shankar, what do you want? Ravi Shankar? Any issues?
You can type your message in chat box, like question and
Somebody raised a hand, so I just unmuted one of the person who raised a hand. Yeah, guys, you want any help? Try in the Q&A window. I think my colleague Alok will look at that and he'll be able to talk, right? So Alok, please look at the Q&A button, right? When he comes there, let me please prompt. Okay. Anybody has any difficulty or something?
Yeah, sure.
So we are going to talk about what is the system, what is the system on a chip, and where does academia stand today, and what is India as a nation, what do we need, and what are the issues we have? What are the gaps? Where we want to be there, and what are the gaps in doing that? What are the possible solutions? How we can solve the issues, right? So we'll see how do we do that, right? And now, what does it take to build a successful career in the system on a chip design, right? We'll look at a case study and we'll look at that. And we'll look at what are tips to become a successful career. We'll talk it throughout the session. And finally, the Q&A, right? So we have a lot of people in the panel. They'll join very soon. So we're getting delayed with their respective work. So we have people with the system architecture, system performance, and people with the design implementation, verification, both on the hardware side and software side, right? Verification, validation, low power designs, PGA emulation and validation, physical design, ATE testing and validation, production, fabrication issues, like the post-production validation. We have end-to-end, right? From system software to the hardware and to the post-production testing, fabrication. We have entire people, and collectively we have 200 years of experience in the panel. So keep putting your questions, and we'll answer all the questions as much as possible, and we'll give you enough time to answer questions. The presentation will try and go very fast, and we're not going to learn anything today, but we are going to see a perspective, right? And finally, we'll see the next steps. So I think many of you have told what you want. We can ask open-ended questions in the registration form. Most of you have answered. So we'll see about that. Okay. So just general disclaimer. So whatever we present here, it's our personal thoughts and ideas. just not necessarily representing the organization what we work for or represent, right? So personal opinion, because we are all working in corporates. So whatever we talk, so keep in mind it's our personal opinion, not our respective employer's opinion, right? And I'm recording this webinar, and once I get all the panelists' permission, I'll upload it in the YouTube. You'll have the link, right? I'll give you a copy of the presentation and the video, so you don't have to record this webinar or take screenshots or anything, right? Please don't do that. Focus on take notes if you need, right? And focus and listen, right? Listening skills are very important, right? So don't do any illegal things, right? And your copyrights are important. We respect copyrights of respective owners. A lot of people have done all the work, so it's not my own work. So it's a collective work. So all the copyright belong to respective people, right? And there is no commercial motive, and we don't do any training or any such activities. We don't have any commercial motive in this webinar. Just for people's interest, so that we get people to work on the electronic and computer industry, right? We're going to give a perspective of career opportunities in electronics and computer industry, particularly from the system perspective, right? Electronics and system software, basically hardware and system software. Right? Any errors are like involuntary, and we have no obligations for any damages caused, right? And so if you want to use this presentation, please check with us before you want to use it somewhere, right? Okay, so as I said, I have 30 years of experience in the industry, also in mentoring, training, teaching experience with chip designs. So I'll talk more about me towards the end of the presentation. I'll do a case study of my own career. So because it's about case study, so I'm going to explain where I started my graduation and how I went, and how I spent 30 years and where I am today, right? I'll give a perspective so you all will understand. So you can ask me questions, what challenges we faced and how did we work, right? So currently I'm a freelancer. So I don't work for anybody. I'm a freelancer. I consult and mentor students. I do any consulting for anybody who wants any help on industry side. I consult. Basically, I'm focusing on skill development. You see the bottom line, the blue color. So I'm aspiring to impact the grassroots engineers through skill development, problem solving, and mentoring, right? So I'm a visiting faculty in IIIT DM in Kanchipuram in Chennai, right? So I do some industry relevant courses like Zenford test and system level verification with system Verilog and UVM kind of things, right? And I mentor my students. I had 40 students last semester, and this semester I have about 20 students. So some of the courses are elective, right? So I'm also a member of Bharat Semiconductor Society, so where we do a lot of initiatives, and I request our lead Bharat Semiconductor Society, Mr. Budan, to talk for a couple of minutes and introduce what is the mission of the society. Budan, are you there? I think it's not there. Okay. Let me briefly introduce Bharat Semiconductor Society. So it's basically society is formed by like-minded people as a non-profit organization registered under Tamil Nadu Societies Act. Right, we have a bunch of people distributed all over India. Right, and so we want to build the nation. Basically, we'll talk about that more as we go. So that's our mission, to make sure that we support end-to-end the ecosystem and develop the skills. We'll talk about some of the Government of India initiatives on the semiconductors. Right, and so the society is basically trying to solve some of the nation problems through skill building, trainings, and working with industry stakeholders to make sure that we'll do the entire thing end to end, basically, right? Whatever industry need, and will help to meet the nation requirements. Okay, what is a system? So let's talk about what is a system, right? I'm going to give you some examples of what is a system, right? So we'll see that. Further, what is the main theme of this webinar today, right? So let's see, we have a theme. I've not mentioned that explicitly to keep some surprise element. So theme is basically the mindset change. So we're going to talk about the mindset change directly or indirectly throughout my presentation. I think Q&A, you can ask what is a mindset. So I'll also express in the Q&A session, but there's something called mindset change. You may know, you may not know, but I'll do overall presentation, course of presentation, I'll talk about what is a mindset change. So please observe various points, right? And we also talk about system and product knowledge, right? This is about a system, right? So we'll talk about that's what is the first topic, what is a system, right? And how do we build products, right? So that's what we are going to look at. So system, right? So you can look at Wikipedia for a more definition system. So system is basically a interconnecting bunch of well-defined components connected together, right? And in a predefined fashion, connected, and it's also running a system software along with it to make all the elements work. So system software is basically brain behind system software is operating systems. I think we all know what is operating system, right? And anybody doesn't know operating system, please put a question in the question answer session. So we'll answer that right away, right? So brain behind the system software operating systems. So that leads and supports the multiple other like things like device driver and the software stack, and finally the application layer where you have, we all know what is an app today because we all have smartphones. We know what is an app, right? So entire thing is basically part of the system software, basically, right? So system software is not necessarily application, but it's right ground level, right from operating system, device driver, and there are various levels of software stack, right? Development, integration, testing, and everything is system software. So we'll talk about more detail. We have slides for that, right? That's basically the definition of a system. What are the examples? Example is mobile phone, as just mentioned. Everyone has a mobile phone. Mobile phone is an example for a system, right? So wearables like smartwatch. I have an example for a smartwatch system, right? So you all know who smartwatch is good. So I don't want to talk about it, right? So we'll see. Wait for a minute. I'll show you the next slide. So smartwatch is a very good example. Computer. We all have desktop computers or laptop computers. It's a good example. And television, right? So there are so many examples I can give. So some of the examples are, this is some of the example, your wireless LAN router, for example, right? Your car, if you have electronic vehicles, it's very mind change games. I think you can follow my LinkedIn post in last 48 hours. I think I posted about one of the posts from Qualcomm, basically how they are going to be aspiring to be a lead in electronic vehicles, EVs, right? So that's extremely important, right? So there are examples for system, right? So let's see what is inside a system. So if you don't understand anything, please put questions and we'll get back, right? So Apple Watch Series 3, there's an example for the smartwatch. We're going to talk about it. Let me see, I can take this pointer. Okay, so you have multiple components that you can see. These are major components, and these are multiple small ICs with capacitors and those kind of things, other discrete components out there. The entire thing put together, this is a PCB. The entire thing put together is a system. As I told, system is a collection of all the hardware blocks directed in a certain fashion, and they're running a system software on top of it, right? So this is a processor, main processor, application processor, and it has a NAND flash. NAND flash is a memory where you can run your entire software on that, right? Into that, right? So it's called flash memory. You all may have read in the colleges, called flash memory. So NAND flash and NOR flash, the different types of memories. NAND flash has certain advantages. You can look at Google to find out what are different memories, right? So this is from Toshiba, and these two chips are from Qualcomm. This is basically the modem chip for the 5G LTE modem chip, right? It's a very 4G network, right? And it has a SDRAM stacked on top of it, right? We'll talk about the later side. I'll tell you what is the stacking, right? You may not know. So please, if I don't attend this question, so please put me a question in the question answer session. I'll talk about what is the stacking, right? So this is a stacked modem with a SD memory stacked on top of it. These two are power management ICs called PMIC. This is one for the application processor and install system, and this one for the modem, right? To manage various power voltages and power ranges, right? And we have a sensing ASIC. It's for various sensors because Apple Watch will have sensors. So this is a chip for handling all the sensor activities, right? And you have another chip. We don't know what is it. It's a guess because somebody has done what is called tear down, right? You take a watch, you open it up, the system, look at the components. They use things like X-rays and whatnot. That's called reverse engineering. They do that, and they do this because Apple doesn't publish the system diagram. So other people, this guy called Tech Insights, you can go to the website and see. Right? There's something called Anand Tech. They do a lot of tear down for laptops and smartphones. Right? You can go to the website. They do a lot of tear down reports. Right? You can just search for tear down or any phones what you have, and they'll give a detailed report. Right? So the tear down report for the Apple Watch. Right? So everything is well integrated, and so you have a memory which is running the software. You have various hardware components, and you have a PCB. So entire this is called system. So that's what I wanted to show you. Right? So next we'll see what is the SOC. So SOC is in the nutshell. I'll not read this basically. I'll show you with an example. Walk through that or ask me questions, any questions. So basically, what we showed in the previous slide, or in olden times, if you have a desktop computer, right? Maybe you ask your father, then you would have seen it. Ask your father or a grandpa, maybe too old, right? So ask your father or uncles or whatever it is. The desktop computer, they have something called a motherboard, right? So it's basically it has a CPU, and it is a bunch of everything, right? The various discrete components, and there are bus slots, like PC interface, and various card interfaces, where you can put various add-on cards, like Ethernet interface, USB. There's a port anyway here, There is Ethernet interface is one example. You can put various interface cards. You can put, there's a PCI interface is the backbone basically, right, to communicate with the motherboard, right? And these are various connectors to talk to various interfaces, right? And this is a USB interface. So on power adapter, speakers, mic, everything. Right? This is a laptop motherboard, right? So what we do is in SOC is most of the majority of the components, including analog elements, they come into the same chip. If you look at here, you have a analog and RF circuitry. RF is a radio frequency circuit, and you have a test lab to test the chip. So we'll talk about what is a test. We'll talk a little bit later. And we have a main CPU for the digital blocks, CPU and a RAM. Everything is put here. And you have sensors and various actuators are there. You have a RF antenna and optical communication blocks are here, and these are various your pins. Talk to the outside world. So majority of things will come here. What it gives you benefit is it gives you basically reliability, it reduces the cost because your testing and maintaining become very easier. You are shrinking and putting everything in a single thing, but you have to make sure you validate and everything, the hardware, software, everything works together properly before you manufacture it. Right? There are various steps. We'll talk about that. Right? In a nutshell, basically, here they have so many problems because it's a board. Anywhere you connect from one component to another component, it may have a lot of issues. So, but this everything is well tested and well integrated, right? So everything is guaranteed to work together, and there's less chance of a failure, right? Your reliability, right? Or what do you call as MTBF? You have heard the name called MTBF, mean time between failures, right? So there has to be very, very less, right? Because when it's thrown on the laptop, it should work continuously for months together without getting reset, right? Your servers or whatever it is, right? So MTBF has to be very, very, very high. Okay. So what is the example for SOC again? Again, I'll not read this. I'll just show you this diagram. So this is a very small example. The actual SOC doesn't look like this. I'll give you an actual SOC example in the next slide. So you have main CPU, this is ARM CPU. ARM is advanced disk machine run by a company called SmartBank, if I'm not wrong, right? Right. So the ARM processor is belong to they license the IPs and people design chips based on those IPs. They're soft IPs typically, right? You have something called a JTAG scan for the interfacing to the outside world. That's for test interface, right? You have voltage regulator. I think you have studied what is a voltage regulator. There's external memory interface. There's on-chip RAM. There's a flash memory, like what these are NAND flash or your software code will be running. Right? This flash programs interface is there. You have data controller. There's a memory controller is going to talk to all the memory into external memory, on-chip SRAM and flash memory to control all the memories. And this is the main bus backbone. The entire chip is called bus interface, AHB and APB. Right? They're a little outdated, but still good to understand for a beginner to understand what is SOC, what is a bus interface. Bus is basically an infrastructure allow you to communicate between one block to another block to the processor, right? Processor can send its instruction, data, everything to the bus, can program, restore the peripherals, right? You all know what is a peripheral, like something like a DMA controller or a UART or interrupt controller or a USB, right? These are the peripherals, you have sort of Ethernet, right? UART, SPI, ADC, DAC, your timing and counters, right? So these are various peripherals what we have. These are system controllers like your interrupt PLLs, right now, and reset controller and power on reset, watchdog timer, and debug unit. And if any of the technologies are not clear, please put on in the Q&A, we'll answer that. Right? So this is a typical example, and this is a backbone of the entire chip. It's called a bus interface. And the latest what we have is the versions of AXI bus, right? And this slightly outdated is a low speed interface, so it's not very high performance. AHB and APB are low speed interfaces. It's not very high throughput, high performance, it doesn't support. The AXI interface is a high performance or high speed interface. They're all open specs are available. You can go to AMBA specification, you can search for AXI, and AHB, and APB interface in the Google. You'll be able to get the entire spec from the AMBA specification website. I would highly encourage, it's very easy to read and understand. So, but you can read self-read and you can read it, and there are a lot of videos on the YouTube if you want to learn. You can easily learn it by yourself. But they are not typically taught in colleges. You can take a note and search in Google, get the specification, read the specification, and look at additional references from the YouTube. Okay. So there are 4 examples I have provided here. And one thing I want to point out is I worked in an industry, I think the name is specified here, Qualcomm. For 15 years, I was in Qualcomm. I'll tell you at the end. Right. So these are the last 4 projects I did when I was in industry 3 years before. Right. These are one of the last 4. I have done a lot of chips. I cannot count how many chips we designed. right? So one of my colleagues also posted saying he completed 10 years in Qualcomm and lost count of how many chips he has taped out, right? I worked for 15 years in Qualcomm, I lost count of how many tape out we did. I worked from 90 nanometer until, yeah, I don't want to tell what technology we worked, that will be company confidential. So I cannot tell what is the latest technology we have worked on. Yeah, but I worked right from 90 nanometer onwards, I worked, right from when it's 18 years back, right? I worked on all the technologies, right? So mobile phone is one thing, one process. You can look at click on this link, you'll be able to see the entire specification of the particular chip, right? So each of the chip are given a link. So what is the unique thing this chip is that at that time, about 6 years back, there is a need to support 8 GB memory space in the system, right? But the bus interface was 32-bit, right? The backbone bus interface I told, the XA bus interface that can support only 32, support only 4 gig of memory. 2 raised to 32 is 4 gigabytes. You can do the math, right? So supporting only 4 gigabytes of memory, right? But there was industry need because the companies were coming into solution. We are designing a chip for 8 gigabit solution, but they want customer wanted immediately some solution in few months. So what we did is we did a tape out in one month or 6 weeks. We did entire chip tape out and using unique methodologies. And we did a chip in record time. In about 4 to 6 weeks time, we taped out and we got the chip back. And in 3-4 months, we sold the product and the product was available in the market, right? So entire team, the system software team, the hardware team, we'll see different teams in typical corporate. I'll show you. All the teams work very together, and I was a lead and I was a design manager for the particular chip. So we work very closely. The teams were spread across various geos, various locations. We are partnered together. We make sure that all the information passed along the day to day with all the teams. Closely work together, and we made the impossible task possible. One of the challenging tasks. So we can talk offline if you have anyone to know, because we don't have enough time. So I'll skip about it, right? And automobile, it's again thing, right? So automobile industry got designed a chip for a car. So that's called Atlas 7. This link will have more details about that, right? Again, we did a question for a company called CSR, Cambridge Silicon Radio. For that company, one team was kind of letting go because of acquisition in Israel. So we had to travel to Israel and get all the know-how from the company and take out the entire chip and do a better revision of the chip in a month time or something, right? It was very challenging again. That's why I'm mentioning it here, right? So every chip has different challenges. So the entire team disappeared because of all the shutdown of that site because of acquisition, right? We will take the entire knowledge, own the entire design, and tape it out in 6 weeks or whatever it is, right? It was a very challenging project. And we did a chip called low power audio. So this for your things like Amazon Echo kind of products, right? So you have Power Island, you want to do for low power audio applications. This particular chip called QCS 400. Then the last chip I worked in as industry was about for the Wi-Fi next-gen home networking, right? So again, it's called immersive home 240 platform. So this is for internal IoT applications for the home networking. Gateways kind of thing is a chipset again. I'll tell you what is the chipset in a moment. So I'm not going to detail for lack of time. So you can go to the links and you can try and understand and reach out to us for any help. Okay. So that given introduction to system and a system on a chip. Why we thought we talk about system and system on a chip before we get to this, because it's the right time to talk. We're talking about academia, right? So when we enter this academia, right? When you say I have seen academia doing the courses like digital system design, digital system testing, right? But if you go and look at the course curriculum and content, they're just teaching about small circuits, right? It's basically circuit design and circuit testing, not system level design or system testing. Because I showed you what is the system. Right? System is this one, basically, right? This is the entire system. So no way in academic we deal with the system, right? So there's a misnomer, there's some communication gap, right? So academic is very good for research. They teach they have a lot of breadth, and they're doing a very good job. They are producing good engineers. We all came from academics, right? Right? And we have academics is very good because I'm in academics for last year and a half or so. So we do a very strong foundation. The professors are very good. All the faculties are very good. They're very knowledgeable. And they're doing excellent work in research, publishing papers and patents on the tomorrow's next gen technologies and everything. They're doing awesome work, and hats off to them, right? But general observation is that
8.9.
It's a general observation is that the curriculum is about 10 years behind, right? That's why I was telling, right? When you say system, they may actually use a circuit. It's basically a circuit design and circuit testing, right? So it's not really a system level thing, right? So it's like this, basically, right? You will definitely reach your goals, but it's like a traveling in a train and tracking in a flight, right? So tracking in a train and tracking in a flight, right? So still you reach your destination, but reach very slow, right? Flight takes you from like south of India to north of India in 3 hours or 2.5 hours. But if you go take a train, it'll take 2 days basically. It'll go from Kanyakumari to Jammu Kashmir, it'll take you 2.5 days, but take a flight, you go in 3 hours. That difference between the industry and academia today, right? So that's what academia stand. But I'm not demeaning anyone. Academia is doing a lot of work, and that's where all of us come from, right? I have a lot of respect for all the faculties, whoever it is basically. Right? Okay. So we'll talk about what does a country need, right? So we need right skilled engineers who are ready to perform right from day number 1 in the industry, basically, right? So that is our need, basically, right? So we want skilled engineers. What is the skilled engineers? We'll talk about that, right? So we will see that. What is the link? It's not working. We'll see in a moment, right? So we want basically with people to create products and solution creators. We have to solve problems, basically, right? So that is what is needed, basically, right? We don't want people to know some scripting or some coding. We don't want that. We want people to solve problems, basically, right? So which is basically not, this is what the country as a nation as India needs, but this is not happening. So if you want to create products, as the Prime Minister said, I would talk about Indian, like one of my friend will talk about the Indian semiconductor mission. So we'll briefly talk about that, right? And we want to solve problems. We want to create solutions, we want to create products, right? We want to make chips in India, not consume chips, right? So we want multi-talented and multi-domain experts when the students graduate from the academic, right? That's what India needs today, right? So what is a multi-talented, multi-domain, right? So typically, it's basically, for example, to design a medical equipment, right? Either designing medical equipment or a fighter plane, right? Or your space station, right? Or it can be designing a computer, simple designing a computer. How many of us know how to design a computer from scratch, right? So if somebody knows, please raise your hand, right? Or put a, I'll come on presentation, I'll come back and yeah, probably I'll recognize that person. Somebody knows how to build something from scratch. I'll give a gift to that person. I'll commit for a gift, whatever it is. Yeah, please, put a message or raise your hand if somebody knows how to create a computer from scratch, right from the entire design, from all the building blocks of the hardware, and they're writing the operating system from scratch, building the entire ecosystem based on computer. Somebody knows how to do that. I'll give them a gift, right? Whatever it is, right? I'll do that, right? So because that's the system basically, right? So we have to do system, software, and hardware. People think software means basically IT. That's what people know today, right? We'll talk about what is system software in a few minutes from now, right? So we need to create a seamless experience, basically, right? It has to work together. So one more example, when we talk about computers and phones, right? So what is the best model, right? We all talk about Mac, right? You all know what a Mac, iMac, right? Mac OS, iOS, basically, right? You have Mac laptops and phones. They're very sturdy. They cost a lot of money, like a Mac or an iPhone. They cost a lot of money, but still people buy, right? I bought 2 iPhones in the last 8 months, right? So you can imagine how much money I spent. Why did I do that? Right? That's because they are very reliable, right? They are high quality, right? So that's why we're coming here. I've come to this point. Quality, and quality is the bottom line, right? So
yeah, Hari,
yeah.
is Raman here? I'd like to add a couple of points.
Sure.
Okay.
Yeah, sure.
So, yeah. So, hey guys, my name is Raman. I'm heading the Intel IP group. My friend Hari, I need to thank him. She's the best visionary because he's helping you guys to come out of this, the deadlock of this recession plus employment opportunities and training, right? I think I really want to thank Hari first. But before what he mentioned about quality, I'd like to echo it because I also have a lot of interns and I'm converting to CG Rex. I'm hiring a lot of people. So we are really looking the students who are coming out of BTech or MTech students. We are looking into more of more than the knowledge, and they may have, for example, I have a guy who doesn't know Verilog. He came from embedded system, but now he's doing formal verification because the attitude what he got is to learn things, and he's putting his efforts even in spite of the hybrid model where he's working from somewhere in the North India. Still he's putting all the abilities and putting the right attitude to learn things. And that's where, even though he's coming from embedded systems, MTech, is able to learn Verilog and system Verilog and doing now formal verification also. So I think I really wanted to echo that, what he said, quality is more, and also the attitude. You have to think about learning capability. That's what we really looking when we're trying to convert into RCG or a college graduate, right? We don't hire. We're looking for the right attitude. So please have that also in mind. Hey, thanks very much.
Thanks, Raman. Thanks a lot for your pearls of wisdom, right? Really appreciate. So we're talking about the Apple, right? Why is Apple so successful? The cost is very high, right? Because they do everything end to end. They write their own software. They design their own hardware, right? So it's well integrated. It's not an open source operating system like Android, right? So the software, entire operating system is designed by Apple. Entire hardware is designed by Apple. So everything is well integrated and they do everything end to end. So they have a high quality because of that, right? So in turn, your cost may be high, but still people buy because your quality bottom line, right? So extremely important. I can go and talk about multiple things there, but your lack of time, we are talking about it. Probably I'll just mention one example, basically about the quality, the cost. Let's say we take an example of aloo paratha, right? So when you want to buy aloo paratha, there are various varieties. You can go to Zomato or Swiggy or whatever you can order, and you see various price range, right? From 50 rupees to 200 rupees, you will get aloo paratha, right? So what is different? Why there is so cost variation for a simple aloo paratha, right? So that's because of quality, basically, right? So if somebody is giving a better aloo paratha, good quality and good stuff, right? With hot everything, right? And you don't pay a little bit 50 rupees more, right? So that's the example what I want to give, right? So extremely important. So like the food industry, I'm just giving simple examples so you can connect it, right? Similarly, like self-reliant networks. So for example, some of the enemy nations, like I don't want to name people, but some of the enemy nations to every country has enemies, right? So they cut the undersea cable, right? We have internet is going through the cable network through the ocean, basically, right? Somebody comes and cuts it, right? Whatever, internet goes off, and for days together, right? We are without internet. Can you live without internet for 5 minutes today? No, right? What if for days together, the entire economy goes down, actually, right? So what do we do? So we need to have our own technology. We should have our own backbones. We have good satellite, but still we should have the network connectivity, right? So we need to come up with self-reliant networks, right? That's extremely important. Defense systems, extremely important. We cannot outsource anything. We have to build everything from scratch, right? So a lot of examples like that, robotics, quantum computing. I can talk many examples. Maybe we can do it one more session separately. There's a lot of things to talk about. We'll not have time to cover all things, right? So we need people to be visionaries, like how Dr. Abdul Kalam says, it's a dream, right? He's one of my, one of my inspiration personality, right? He came from a very, I'm going to talk about like what my thoughts. I'll talk about in a few slides from now about Abdul Kalam, right? He's a visionary, right? So he said people to dream, right? You can read a book called Wings of Fire. I don't know how many have read that, right? He says people to dream. Like he had a vision 2020. So we are 2023. I don't know how much of vision is fulfilled. No idea, right? We have to go and check back, right? So we have to take risk, right? Risk taking is very, very important. You cannot sit a soft zone and take this work. You have to take risks. Things will go wrong, but you have to take that risk. It's extremely important. You want to create a solution, you have to take a risk, right? It's extremely important, right? And you want deep technical thinkers. So you have to think. But then we'll get ideas, we can create products, everything, right? So we need people to think, right? So high quality price at the right target price, that's our bottom line. That's what we want, right? Just because of high quality, we cannot sell aloo paratha at 5,000 rupees, right? It has to be 500, 200, 550 to 200 rupees. Sell it for 5,000 rupees or 2,000 rupees, nobody will buy your aloo paratha, right? So you have to get the right target price, right? So even the Apple sells a high price, they cannot sell a phone at some 10 lakh rupees, right? So it has to get 60,000 rupees, then people will buy. They cannot sell 10 lakh rupees, very few, handful of people will buy, right? So it has to get appropriate target price. So let's quickly go and look at what are the gaps we have in the whatever industry wants and what students are there, all of you. And I'm not, this is a general observation. As I told in the beginning, this is a personal observation, basically, right? With our industry experience, I've recruited a lot of people who travel all over India to various colleges, right from IITs to BITS Pilanis to the local colleges, also what we call Tier 2 or Tier 3 colleges. I've traveled all across the country. And I found this is a problem, and that's why I quit, and that's why I took this passion. I want to solve this problem, right? That's why I'm here. So engineering fundamentals in electronics and computers, so that's basically lacking, right? So people know fundamentals, but you ask them how to apply that, right? So that's what you say. You know the concept, you know what is a D flip-flop, you know what is a counter, you know what is a ALU. But if you go one level down and two level down and ask how do you apply that, and go next level down, ask you basic, can you design from scratch? Can you show in terms of transistors, can you design a ALU or a counter, right? You will not be able to do it, right? Somebody can do it, please raise your hand. Right? I'll ask my colleagues to write down who is, can you design a counter from using transistors? I think, I don't know. The two people raise their hands. Hello, can you write down the names? Who raise the hand? I'll three people raise the hand. I'll talk to them offline. Please write down the names. Hello?
Yes, sir. I'm
Yeah, please. Yeah, thank you. Hello. I can lower the hands because we are writing it down. Right? So, connecting the dots, we learn many things. Then how do you connect the dots? Right? So we read too many courses. We read academic. We read analog design. We read digital design. We read about computer architecture. We read about embedded systems. We read, and we read about semiconductor device physics, and we read about IoT. We read about communication systems. We read about digital signal processing, and we read about operating systems, system software, whatnot. We read so many things. But how are these things related together? From a system point of view, right? We talk about system. All these things are needed. What did you learn in academics in 4 years? They are all needed. So people are not fools. Who came with the curriculum? They are all top brilliant brains of the country, right? They are all done PhD. They have done research. They have put their experience. They have designed a curriculum, right? So every single course, what you learn today, it's not a waste. Every single course is useful as long as you know how they are related. That college is not teaching today. That's a gap what we want to solve. You have to connect the dots. You have to connect whatever you learn. You should be able to connect, build up a system, right? Study is not happening. That's what we want to do, right? And practical knowledge is that can be built from scratch. I ask a question: can somebody build a counter using transistors? 8-bit counter. Can it be up-down counter? Can it be counter with a load? I'll give you more. I'll keep increasing specification. Can we do trade-off with the power, performance, and area? Can you do a trade-off? Right? So who raised the hands now? Please raise the hands again. Right? Who said they can design a counter from using transistors? Right? So can you do all the trade-off and show me which is the better circuit in terms of power, in terms of performance, area? If I'll give you something called KPI, the key performance index, you should tell which is the best solution for the given KPI, right? So who raise the hands? I'll talk to them offline after this conference or tomorrow. Okay, so that's important thing. So that is not there. That practical knowledge is needed, right? How to build a processor from scratch. For example, RISC-V is the hottest topic in industry today. How many people know about RISC-V processor? I do not know, right? Can you design RISC-V processor from scratch? Okay, Sashank says, very good, Sashank. Right? So we have to build from scratch. Can we write our own tool chain? Can we write our own compilers? Right? That's the next thing. Can we write our own operating system? Let's say I had some custom instructions with very specific DSP specific instructions for my. I had multiple pipelines. Right? I had 3 pipeline stages or 4 pipeline stages. So can you write a tool for? Can you write a compiler for that? Can you write an operating system for that? Can anyone of you write? Please raise your hand. We'll write it down. Right? So system knowledge, which is not there. All this is system knowledge. You have to be able to design, you should be able to verify, you should be able to validate, you should write a system software, you should be able to write operating system. Everything is a system, right? That system knowledge is not there. That's what I think. If you have the knowledge, please let me know. I'll be happy to learn from you. Right? And what is actually another drawback what we are seeing is real project execution skills at academic level. A lot of people come and ask me, sir, what project should I do? Right? What should I do? I tell them something based on their knowledge level, right? But really what we do is, basically, the answer is here, right? What are most of final year projects, what our academic will do? They're in industry standard, they are more like a lab exercises kind of thing for us in the industry. Right? They are not, for you, it may be a project, it may be lab. It's like an LKG student, right? Oh, I know how to write a word. I know how to spell a cat, right? But you are a 10th standard student, you can write a paragraph, you can know how to write an essay. It's like that, basically, right? So our requirement, we are like people to understand things, do a real projects, but academic students are not there, right? We do a real life project. It's some system. That's what I mean the system. The electronics and computer science have to work together. If somebody is doing a course like electronics and computer put together, I would love to mentor them, right? I know there are degrees like electronics and computer engineering together. Some people do a dual master's degree. I was talking to one of the students a few hours back in US, and he was doing a dual degree with both in electrical engineering and computer engineering. I really good that he reached out to me, and I'm going to be mentoring him for a period of time, right? He's just doing his 3rd year now, and I already committed to him that I'll definitely help him at any cost, right? So I want people to appreciate all the aspects of the system, like computer and electronics together, right? So you have to, people read an academic side, but they don't know how to link it from a system point of view, right? So you have to do a project at a system level, right? You work with the electronics side, you work with the computer guy, and computer engineer should work with the electronics engineer guy and come with the system. So that's the approach what we want to follow, right? And we'll be glad to help you if you have come with some ideas, we'll be able to mentor you. Okay. So what are the possible solutions, right? So constant review and update the curriculum, right? We said a curriculum is 10-year-old in the previously, right? So curriculum has to keep up. Today we had even a curriculum in 2023. 2025 come and say that curriculum will be outdated because industry moves very fast. You all see the 5G standard, right? For example, who knows understand the communication side? 5G standard came up in, so remember a few years back we were in 2G, right? Where all the scam, everything happened, right? I don't want to get into politics side of it. 2G happened about 10 years before, right? Still few years back, there was a court case was going on, right? So people are talking about 5G implementation today in India. 6G, 5.5 or 6G will come very soon, right? The technology moves very fast, very rapidly, right? So similar to the memory side of it, a lot of technology they move very fast, very rapidly. So curriculum has to be updated on periodical basis, like every 2 years or whatever is it. It has to be constant update. It will become outdated. Right? So what we bunch of people what we commit to do is we have to mentor and train students to meet the needs of the nation, part of the academic curriculum. So that's why we are here. We want to. I already announced it in the LinkedIn today a few hours before. We have a channel to mentor students. It's using. So we'll talk about that towards the end of the presentation, right? So we have a team of people who are ready to help mentor you. Mentoring is not training. If you have a problem, we'll tell you how to solve it. We'll guide you. That's mentoring, right? We are not training. We are not teaching. Mentoring is you have specific doubt, how to go about it. We'll give you pointers. You have to go and read. You have to do the hard work. You have to come with the solutions, right? We'll just give pointers. That's mentoring, right? I'll put up. I posted 1 month back. I posted what is the difference between mentoring and coaching. I'll repost it again, right? Later on. Right? We want to provide all the materials and resources, all the labs and projects, everything, and enable the faculty to conduct courses. That's how we can scale it fast. All of you are ambitious. There are about 143 people attending this webinar, right? I'm sure all of you want to work for Intel, Qualcomm, Broadcom, and Nvidia, and Marvell, right? Or AMD, whatever. I'm just naming a few companies. I'm not biased towards any companies, or Texas students, or Samsung. I've met so many people last few months. Everyone wants to work on a product company. Everyone wants to work get a high salary. You have to be ambitious, I agree, but you understand the reality. Are you capable of delivering to the industry expectations? Ask the question yourself, right? I always tell my students, engineering is asking basic questions like when, what, why, and how. These 4 questions you can ask any doubts you may get. Ask why, what, when, and how. You can come up, frame the questions, 50% of the problem is solved. Then you can answer questions, 100% of the problem is solved. That is all is engineering. To me, engineering is basically asking 4 questions, answering 4 questions. Why, what, when, and how. If you're making notes, please take a note, right? Extremely important, right? So we'll enable the faculties to conduct the courses and we'll support them, we'll train them, and we'll mentor them, we'll mentor faculties, we'll work with them. But that's how we can reach out across the country, right? If I want to train many people, I'm going to talk about it in a minute, right? What I want to do. I'm going to make an announcement very soon in a minute. Just wait for that. I'll hold my thought. Let me talk about this. Right? Focus more on rural areas. I'll just jump and go here. Dr. Abdul Kalam is old. He's my inspiration, right? So he says half of the population of the world lives in rural region, not in India, entire world. They are in rural areas. Majority of the people may not speak English. They speak local languages, which is fine and acceptable, right? And they are in a state of poverty. The economic level, if you look at India, the rest of the world may be high. But in India, the poverty levels are, like the overall economic level are very bad. I don't know what is the average salary in India. Any of you know, please raise a hand. I don't know how many thousands of rupees average salary in India, across India. Somebody knows, please. Any of my panelists know what is average income in India, monthly income? Raman or Srikanth? You know the panelist? You pitch in if you know. Yeah. So I don't know. Yeah, you can do a Google research and find out, right?
Hari, go. Sorry, I was on mute. Go ahead, Hari.
I was asking, do you know what is the average salary income in India?
I think you are looking at probably not the average salary, right? It's basically the for every person, how much is the actual dollar of really how much a person is worth, each person in this country.
Right,
that's
right,
what you're
yeah.
asking.
Oh, you call it net worth.
I'll get it to you.
That'll be, you can tell the students, they'll know what is the reality, right?
Yeah.
You want to focus more on rural areas and on those in need of the help badly, right? So what I announced, so please listen carefully. I'll make an announcement. I'll post on LinkedIn after this meeting, right? I'm going to mentor 10 students from rural areas. Preferably they need help badly, right? What in terms of whatever it may be, right? They want to aspire, they want to come up in their life. They may not know how to speak English or understand English. I can talk in local languages. I know Hindi, and I can get people, some of my colleagues here, they can speak Punjabi, Marathi, Bengali, and all. If you can speak South Indian languages. So wherever you are, if you don't know English, don't hesitate, reach out to us. Your rural areas, we love to connect with you, love to help you. I'm going to mentor 10 students across India from rural areas for the 3rd year and 4th year and beyond that in their career also, right? I'm going to pick up 10 people in a year, right? This right from this academic year, who are going from 2nd year to 3rd year, I'm going to conduct some tests. Please wait for my LinkedIn post. I'm going to announce that. So we have a mechanism how to do it. So whoever wants to, from the industry panelists, who want to join, please join me. This is my personal initiative. I'm going to commit myself to train 10 deserved candidates across in rural areas. Even if they don't speak English or any common language is okay. But pick such people who are really desperate to grow, provided they have that firepower, right? What you call firepower, right? And right attitude and aspiration. You want to help them, right? This is my commitment. I'll make an announcement formally. Thanks for
One
again.
thing- Yeah, one thing I want to add, Hari, in this point of after the COVID era, the online mediums are pretty high. For example, LinkedIn Learning or Udemy and all these places, the learning opportunities are very high. So I expect, as irrespective of rural or urban states, students have this facilities to learn things faster and better, right? And moreover, I think somebody's asking about the salary. I think that varies between the corporate companies as well.
We'll
And
answer the question then, Raman. Sorry, we'll answer then. We'll finish the presentation, right? We'll get back to the question.
what was the question? I'm sorry, Hari.
No, I didn't ask any question. You wanted to say something, right?
Oh, okay. So, okay, I thought some question was raised, but I think generally, I'll tell you guys, I mean, general trend on the compensation, right? Indian salaries are.
Can we take it? Can we hold on for some time?
Okay, then I'll
run through the
yeah.
presentation. Just 10 minutes. I'll finish it. Now we are running out of time. We'll just walk too fast. Okay, so this is very important because you have to understand. You all want to work on product companies. How a typical product company is structured. Please understand what are the various job roles. I'm slowly going to get there. What are the career opportunities, job roles? But I'm setting the expectations basically, right? Unless I tell you this, if you talk about job roles, you will not understand. There's something called product marketing team who interface with the customers. They define the specification of the product, understand customer needs. They come with the product requirement document called PRD, right? So that's the first team. What you have. It's very crucial and important to understand customer requirement, their timeliness, what your competitors are doing, come with the spec, price range, and everything. So define the product, right? Then after that, they give the inputs called a PRD to the system and architecture team for the key performance index. KPI is the key performance index. What speed the system has to work, what performance, right? What is the power, what is the area, what is the security like, what is the thermal issues, what is the thermal requirements. So you define all the KPIs, right? So in terms of respective units, you define your systems. There are various systems. There's something called chipset. There's a bunch of chips. You definitely companies like Intel or Qualcomm, they do a bunch of chips. So one chip customer cannot use is buy a set of chips, 3 chips or 4 chips together to make a system, right? That's called chipset. You have chipset system, chipset architecture teams, the chip architecture team and system. There will be a low power team. There is a system software, everything, right? We have various teams when it's system architecture, right? There are multiple teams working in this particular umbrella, right? So once you have the system spec and architecture spec, right? So then we have execution, right? So execution means basically you have to design from the architecture. Once you have architecture spec, you do a design. Then once you design, we have to integrate. Then after integrate, we have to implement. We have to implement it. I think it's the other way. You have to implement, then you integrate. Or both either way, it's in a loop, basically, right? You have to implement. And then we have to verify, right? So all the things after that's execution, basically. Then if you make a product, you send it for your production. Get the chips back after manufacturing. You have to do a product level testing. Make sure that the silicon is working. Then you have to do a performance scenarios, performance sign off, system performance test, right? So some of people here, like Raman, he spoke, and some of other friends here in the meeting, we'll talk about system performance. If we have any questions, right? Or we'll have dedicated webinars on this kind of topics. It takes time, right? So you have to make sure that your performance KPI is what you defined here. Are they meeting? Can we sign off on that, right? So that's what we'll test it here and find out. Does it violate any KPIs, any trade-offs? So we'll check all those things. We have to make all the KPIs still meet your performance. When a deployment and customer support, how does customer use it? What issues you face? So you have to deploy the customer side. Believe me, that's not easy. You have worked in your lab conditions. When you go to real world, you have unplanned customer have different kind of use cases which you would not imagine. You have to make it work, right? Extremely important, very crucial. It's very challenging, right? So people don't want to work. I know designers want to work on design. Oh, I want to do a architecture. Right? I've seen a lot of people think I want to do architecture. I want to do a design. It's not possible for a fresh graduate to do architecture or design, to be brutally honest with you, right? So a lot of you have to understand the back-end issues like deployment issues and everything, right? Then only you'll be able to get into the design architecture and systems and other things, right? It's extremely important to understand everything end to end. You want to go up in the radar, right? So typically people talk about implementation and verification. That's why they say take a career. But product testing, that's why we start the career in these areas. Then we go to other places, basically, right? We will talk about it in a minute. So exactly, we are here. That's what the main agenda of the meeting. I think we're running a little bit late, but I'll speed up. 2 quick slides to show you that people talk about recession, right? I want to answer those people who talk about recession. So please don't ask questions, but I'm going to answer you right away, right? So this ups and downs is part of the industry, right? We have seen many recessions. We have been in industry for 20 plus years. We have seen 3-4 recessions so far, minimum, right? You can see a dips here, right? It's a periodic wave. It's like a sine wave. So is a recession here around 2016-17. Is a dip here in 2020. There is going to be a dip here also now, right? Slight dip. So it's a forecast basically. It's not actual. When people do, maybe they would have predicted it a couple of years before. During COVID times, you are very, you are very pessimistic or whatever, or very optimistic. You are very optimistic. Somebody predicted this, but actually it may come down when actually it comes next year, right? This is from a WSTS, the World Semiconductor Trade Association systems or statistics of World Semiconductor Trade Statistics, right? This is an organization, global organization. They work on, they collect all this is a global billings, basically, right? What is the overall billings year over year, right? And next slide is going to talk about what is the profit, basically, right? In billions and in terms of percentages. So you see, red color is a percentage of profit. You go into negative, this neutralizes the zero. That means you have no profit, no loss. Make a loss here, you make a profit. This is also like a sine wave. Approximate it, it's like a sine wave, right? It goes ups and down. So it is very normal. Don't worry about recession. It will be the matter of time. Nobody can predict. If you ask me a question, sir, tell me how long it will take. Nobody can answer. So some of the periods are very large here. You see, it took long time. These 2 recessions here, but these 2 recessions are very short. So you cannot predict how long this recession is going to be. Nobody can predict. Only market can predict how much people can spend, how many cars you can buy, right? It depends upon that, right? Because most of the people are working on automotive and that's a hot thing today, IoTs and everything. More systems you buy, companies will sell products, produce more and more profits they make, right? It's economy, right? If you learn economics part of your education, you understand that, right? So it's going to come back, but nobody knows when it will come back. Please stay calm. Yes, you will definitely bounce back, right? Okay, so what is the semiconductor ecosystem? So briefly, I want to talk about it in detail. We have something called design ecosystem, manufacturing ecosystem, and tool ecosystem. So we're going to talk about 3 ecosystems, right? Manufacturing is basically those people who have foundries. Intel, Samsung, TSMC are one of the top foundries. There are many manufacturing companies. The 3 are main companies, basically, right? What are the design houses? Right? You have Broadcom, Qualcomm, Texas Instruments, and there are many more companies, right? Right, Marvell. I can keep adding many companies. There are many design companies, right? And who are the EDA tools, the tool vendors who design tools for us to make designs, right? There are companies like Cadence, Synopsys, and Siemens. Minter was acquired by Siemens, so it's slightly outdated picture. The company called Siemens, the top three players in the industry. So they developed tools. So all these are ecosystems. So everything they have to work together. There's a lot of overlaps, as you see, right? So what people need to do? So people need to have a major in computers, communication, electrical electronics. That's why I spoke about people doing computers and electronics together, or communication and computer together. Whatever combo it's basically, you're doing dual masters or dual bachelors, or there are a lot of combos available in the system today. If somebody is doing that, I'll love to talk to you offline, right? So the skill set and specification needed for every job varies. The job description, what you call, right? They are different for different things, basically, right? Just give me a minute. Right? So we'll talk about each of the circle in detail, right? So we'll talk about the design, right? So what a design means, design engineer has 3 roles. There's analog components. This system, this particular thing, if you take cell phone, there's analog components. These are analog components. So whatever, you have a RF part that is basically your power amplifier, antenna, etc. And you have analog systems basically here. You have ADC and DACs, right? That's mixed signal analog. Then you have a CPU, DSP, and those things in the core. We have CPU, DSPs, ADC, DSP here. They are here basically. You have mixed signal components. So everything is a system. So design engineer has to. So you need a roles for. We're going to talk about analog design engineer. What is the requirement for them? Or if you want to become a digital design engineer, what you should know, right? We're going to talk about that in detail in a minute, right? So we will go to the next step. We'll not spend more time. But for an analog design engineer, so you should know typically what is the analog block design flow. When you want to design a filter function, for example, right? How to design a filter, right? So you should understand the specification. Then you should be able to simulate the specification, right? And you should do a transistor level schematic design. Using the schematic tools, using terms of CMOS transistors, you should be able to do a design using a schematic entry, right? And verify that using simulation tools. There are many tools available, even in public domain, you can verify that. You can do layouts. There are layout tools available for free, right? So there are tools like Magic, and there are various tools available for you to do layout and do a simulations, extract and simulate. There are free tools available. You can make use of that and you can learn, right? right? So a lot of things are available in public domain. So you don't, the college doesn't have tools. It's easy to learn. For learning specific, they are very good, right? So design optimization are done at transistor level. So extremely important to understand the circuit behavior. Analysis is necessary. That's what I told in the beginning, right? You should know to solve problems, right? Unless you are good in this, you cannot become a good analog design engineer, right? You have to have a deep understanding of circuit behavior and analysis. That is mandatory. So it's not necessary, it's mandatory, right? Recommended coursework. What are the things you have to do? Circuit analysis, signals and systems, semiconductor devices, circuit design. So actual course name may vary from college to college and university to university. But typically, these are the kind of topics what you should be mastering. You should be 100 out of 100. You should be getting a A grade or S grade, whatever it is, right? Should be really sharp. Any question asked, wake you up and ask, give any problem in this topic, should be able to solve them, right? Not just a fundamental, should be able to solve problems, right? So that's what is needed for an analog design engineer. That's expectation. Digital design engineer, right? It's another thing, right? It's basically you have to write a block level HDL design in Verilog and HDL based on the specification. Right? HDL, you have to do a logic synthesis. Parallel, you verify using the system Verilog or UVM, those kind of technologies. Then you do a layout, then you back on design and you extract the timing, go back to verification, go a bunch of static verification, then you send it out to the fabrication to the GDS2 format, right? We talk about manufacturing in a moment, right? So what is the recommended coursework you have to do? So that again, you have to do a computer architecture course, logic design course, microprocessor. You have to be very thorough in all these things. Ask any analytical questions, you should be able to answer, right? Any of you want any mock interviews, please let me know. We can schedule that. I cannot, if you are all 150 of you ask me, I cannot do it. Over a period of time, you allow me over the weekends. I can do one mock interview, 1% interview at a day, right? Let me commit for that, right? So please, maybe I'll send a Google form. You can fill it. Then from there, we'll take it up and do, right? I can really help on those kind of things. Just spend 1 hour with me. I'll really show you where you are. I did a mock interview with one of my students last week. I told him he's 4 out of 10. He doesn't, I won't hire him. I told him on the face. He also agreed with the assessment, right? So that's where typically average people, there are exceptions out there on either side, saying normal distribution we take, that's where majority of people will fall today, right? So these courses should be really thorough. Any problem they give, you should be able to solve it, right? Again, in terms of tools, maybe I'll write an article and there are a lot of such articles and the thing, but probably I'll do one of my whole period of time will come and do an article. A lot of public domain tools are available for synthesis, present route simulations, right? Timing simulation, there are tools available. There are some limitations, but good enough for people to learn. So don't tell me that my college doesn't have tools. Right? We have tools, we'll have resources, we'll give you. They may not be industry standard, but good enough for you to do a project. Right? Tools development engineer. Again, right? It's one of my pet area. I was talking to some of my colleagues yesterday and today. So we want to develop some tools. So we need people with good, graph theory and C++ programming and everything, all the knowledge, right? We can develop EDA tools and put it in public domain. How people have developed Magic and or any tools. Right? We don't have a good tools for testing. We don't talk about DFT. There is no open source tools. So I want to design a tool for testing. I want to design a tool and put it in a public domain. But who will do it? I want good students who want to work on such projects. We'll give you a spec. We'll give a statement of work. One of my colleagues told me we'll work on the spec. So we'll give the spec to you. You come with a project kind of document kind of thing, project execution document. We'll review that, give approval, then you go and execute that. We'll review time to time, right? We'll get you enough funds. If somebody wants to do it, we'll get you funding also. I'll pay you a internship stipend or whatever it is. So all those things are possible, right? But we want people to be passionate. It's a combination of electronic engineer and computer engineer. It's a tools. It's both electronics and computer engineers. We have to work together, create tools. Right? Because computer engineers know the graph theory and programming. Electronic theory understand the use cases. Right? So they have to work together in pair. It's system knowledge, basically, right? Manufacturing, right? So we're going to end in a few minutes, in a couple of minutes. Then we'll go to question answer session. So manufacturing is basically a tedious process. You have to create a photo mask pattern, map it to silicon wafer. There are multiple layers. Right? When you say wafer, there are multiple dies. I'm going really fast, but we'll do a detailed sessions in coming weeks. We'll talk about that in a minute. Right? So all those things are going to happen, right? And so then we have to set a good part to the customer working part. That's the process called testing. But once you manufacture, you have to qualify the chips and send it. That's called validation and testing, right? So if you want to aspire for a manufacturing job, a manufacturing role, you should be very good in device physics. Your chemistry has to be very strong because a lot of chemicals, everything, process etching and those kind of processes are involved, right? Metallization, etching, there are chemical is involved, right? So chemistry is different, chemical is different. So you should have a good knowledge of both. And electrical, electronics, and mechanical engineering also is important. You go to manufacturing, right? Right. So a lot of majority of jobs are typically located at the fabrication foundries like Taiwan, Korea, and USA. So today, as we talk today, that's where the fabs are located, right? But except for test engineering job, testing can be done remotely. We have ATE machines everywhere. We can be done remotely, but manufacturing is done predominantly in big three countries: Taiwan, Korea, and USA. I think those who are following my LinkedIn post, I keep sharing posts every alternative day about various issues. I don't want to talk about like a US-China like war, like people know about it. I don't want to talk about and at time, right? So I'll start you the slides. You can go through it, but we'll have dedicated session for each of the slides later on. Right. So India fab in making. Most of you might know, right? India and US are heavily investing on the fabs and semiconductor manufacturing. US is doing that. There's a particular campaign going on. I forgot the name. I cannot recollect off the cuff. There's a campaign going on. India also a campaign going on. Many of you would have. So we're going to talk about that in a minute.
The US one, sorry to interrupt. The US one is called as CHIPS Act.
CHIPS Act, yeah, CHIPS Act, yeah. India, it's called India Semiconductor Mission India, Semiconductor, whatever it is, right? We're going to talk about it in a minute, right? So thanks, Rick.
That's correct.
So we have a firm called Vedanta, right? So what are opportunities? There are going to tons of opportunities. Wait for a minute. Chip fabrication, chip packaging, testing, and qualification in factories. Now we are going to have a fab in India, right? So we've got a lot of more job responses, job roles is going to open up in fabrication, packaging, testing, qualification. These are not there in India today, right? Look at, we're going to be over 1 lakh people will go to create employment. But where they have to be very extremely skilled. None of the engineers can do such a job today, right? So how do we do that, right? So Vedanta had a CEO from abroad, from US. Is a NXP. I posted in LinkedIn a few weeks before, right? Somebody from NXP is joined Vedanta as a CEO. When American is coming into India and working, he's going to get all the NXP. He has a lot of knowledge on fab side, right? He's going to take over the Vedanta as a CEO and he's going to help us. And Vedanta has a MOU with the government of Gujarat to set up a fab. They're going to spend a whopping amount of 154,000 crores. If somebody can count number of zeros, I'll be give a clap to them. Cannot give a clap to them, right? So it's a huge amount, huge investment over a period of time, right? 154,000 crores. Vedanta is investing. The government of India is investing. State governments are investing. 1 lakh jobs are going to create. There are niche jobs, new jobs, but you need to be knowledgeable, right? There are jobs are there, but people are knowledgeable. If you are knowledgeable, you will get jobs. Don't worry about the jobs. Don't worry about the salary. We are going to talk about that in a minute. Swapnil, are you there? Can you just talk about this slide for a couple of minutes? If you're there, Swapnil. Okay, I'll talk about it other ways. No problem. Right? So this is bubbles. Some bubbles are big, some bubbles are small. They're varied size.
Sure.
That depends upon number of people they work. Yes, Swapnil, go ahead.
Yeah, that's fine. You can explain.
You go ahead, Swapnil. Let it crisply summarize it. There are a few more slides to go. 4 more slides to go.
Sure. I mean, this is the size of the oval speaks about the number of people generally are working in this particular area in India. So software design and implementation, which typically has the programmer community as well involved there. Software integration and deployment. This is a huge area. There are many people who are integrators and deployment oriented. Entire service industry is almost dependent on the 3 aspects like software testing, software support, and software integration and deployment. A huge job opportunities over here. And then we are having software architecture, software performance, software tools, and software project management roles at various levels. So this is, in general, we can have a total career in the software. Again, people generally, when they come out of the graduation at the bachelor's level, everybody wants to go to a coding side or programming side of it. But that's not the one and the only career possible. Many people are there, and other panelists may definitely support this, that people have built successful and great grand careers in terms of money, fame, name, everything in all other areas as well. The next slide, please. And there are some misconceptions, but only few are listed over here. Uh, about 99% plus students think that architect job is the supreme job. That's the misconception. Then testing is less priority or is inferior over developing. That is yet another misconception. When we try to hire people, and then if we try to offer the testing job, people straight away deny that. But instead, a good tester is required to know the development knowledge as well as how to break the system, that kind of knowledge as well. Otherwise, that job is meaningless. In my personal opinion, uh, the person who can be a good tester is already a good developer by default. Then either testing or integration or support is not challenging. Absolutely not. In fact, more than the coding or developing, real world life challenges are more in the testing, integration, or even support. Another misconception is that I'm hardware engineer. Why should I know the software coding, or vice versa? If I'm uh, uh, software engineer, why should I know the hardware concepts and design? Um, there are these are misconceptions, as Hari previously told, that if we want to design a system for medical, or if we want to design a system for space station, then across domain information is definitely required. Apple example was given earlier in this presentation. If you know the hardware, then you can write the super performing software or low power software. But if you know what are the problems that software faces, you can design better hardware. Today we are having that, for example, JPEG decoders or video decoders. We are having those particular modules or algorithms implemented in software, but most of them are now getting implemented in the hardware as well. So multi-domain, multiple aspects of a system are definitely required over here. And the people who goes to the service industry, they have a mentality that if I become a project lead or manager very early, like 3 to 5 years, then I'm successful in the career. That's a big misconception that students generally carry when they graduate. And then the last and the most important is that even Raman sir also told about attitude. So I know the first question generally that is asked, that how much on the scale of 0 to 10 you know the C programming, or you know any concept, and people generally answer 8, 9 in that range. But honestly, even after 20 years of a deep technical development in that C programming, the person may not be able to claim even 1% of the C a person knows. It's not about knowing the syntax. Syntax can be completely mucked up. 100% a person may be knowing, but really how to use that particular language to solve the real world problems. Do we really know that? That's the problem. So I know is a big misconception. Learning never stops. We have to keep learning always. And here probably I will hand over back to Hari.
So, Swapnil, thank you. So, what I'll do is I'll let Srikanth talk about this slide. So, after that, we'll pause it. I'll open it for Q&A. Then, if you have time, I'll do rest of the slide, or we'll do almost separately, right? Srikanth?
Yeah, hi, thanks, Hari. One thing I wanted to answer before we go ahead is there was a question about the per capita income in India. And this is of the order of about $1,000 per year, you know, if you consider the whole population of India. So basically what it means is that in a month, the average, if you go by average USD, and of course you can convert it to Indian rupee as well by just multiplying by 80, is less than 100 per person who is actually having an income in India. So that sort of gives you an idea of how low this is compared to some of the engineer salary. I always say that this is one of the most lucrative fields to be in VLSI side, and that is something that people have to have it in mind. Quite a few of the people here earn probably more than what the President of India does, and that's a fair statement to say, simply because the amount of importance that is given to this field The number of people who work on this is pretty less. So semiconductor is very crucial in that aspect. So let me just quickly walk through what is the reason why, there is so much focus on Indian semiconductor mission. So actually, I will just give you a small data here. So today, 27% of our total imports is oil and 10% is electronics. 10% of our total imports. And there is expectation that over the next 8 years, which is by 2030, the electronic imports will actually exceed the oil pool imports. Now, as you largely know, today there are so many different choices when you want to sort of get rid of oil. You have renewable energy, you have hydrogen, you have various other approaches by which you try to reduce oil consumption. Is there a way to really reduce electronics consumption? I don't believe so. In fact, it's going to get more and more. Look at how many things that are being done today, in electronics, and how many things you buy, starting from your probably smartwatch all the way till, your Bluetooth headphones. There are so many, maybe each and every one of you engineers may have 4 or 5 items, and it increases over time. So there is a genuine interest in India to see how they can build some of these, because today there is otherwise so much amount of electronic item being imported. So India is looking at 4 different areas, right? One is semiconductor manufacturing, another is semiconductor displays. Now the displays are something like the display for cell phones, but it is more complicated display like the AMOLEDs, which are currently not being manufactured in India. The third area is semiconductor packaging, and the fourth area is to actually give the support for designing systems. So this is called as a DLI. Now, just before we go into the details of this, and I'll spend probably a minute each on each of these areas. I think the reason it is done for is 2-3 things. One is the long-term strategy, where country wants to reduce the amount of dependence on imports. Second is they want to create a trusted semiconductor ecosystem chain. And that way, it is not about, creating a semiconductor, IP, but it is also about, being able to package it, being able to put it into a system. And that's why system design is such a crucial thing as well. And also the third thing they are trying to do is look at early stage industries and then funding as well as tool supports. So these are various things that the government is trying to do. Specifically talking about DLI, which they call design linked incentive. Primarily it's of 2 types that the government is trying to support that. One is the financial incentives and another is on the design infra side. On the financial side, of course, without going into too much of details, it's tied to the amount of product that you can sell. But specifically on the design infra support side, they actually are trying to subsidize the fabrication cost as well as the tool buying cost of design houses, in order to create both companies which design IPs and also companies which actually design products. So I think the intention of the government here is to see how we can design more and more products in India, and how can more and more IPs be done in India in order to create a self-sufficient ecosystem. So that is the thought process behind it. Now, without going too much into, again, details, there are lots of details into this, and I don't want to spend time on that. However, I do want to talk very briefly about the chip to startup ecosystem. And I know that, the various possibilities that I think Hari talked about is not just going to work in a company, but you can be a part of a startup company as well. And you can do some of these things. So government basically knows that these EDA tools are very, very costly, and they are trying to see how they can actually subsidize it for some of the startups. So actually government is trying to say, okay, very specifically, it is trying to subsidize about 100 plus ASIC companies which are creating ASICs or involved in designing of a IP library of some sort, or also working with prototypes and other hardware basically implementations that can be checked into a system. So these are 2-3 reasons why, or 2-3 cases where government is trying to subsidize the amount of money people need to spend, because these are areas in which huge amount of investment needs to be done, and particularly MSMEs, which they call micro, small and medium size, companies cannot have the amount of cash which can be spent on this. So government is trying to subsidize that. And they actually are also closely working with hundreds of educational institutions. In fact, some of your colleges which you are from may also be working with the government on this. They do participate into Chips to Startup program. So you can check in your college whether they do that. And, government is working with, apart from these and the MSMEs, in order to find various ways, by which they can help the ecosystem to develop. So in fact, this particular Chips to Startup program, it pretty much encompasses every electronics area, including academics, industries, startups, and R&D institutions. Quite a few of these are working together. So I think, I really don't want to spend more time on this. Just in case if there are any follow-up questions, you can ask during the question time. But this should briefly give you what are all these three things that Hari has put in there, in order to show you what are the support that you are getting from a government as an entrepreneur.
Thanks, Srikanth. It's fantastic. So this is what to tell, not only jobs, students have also a chance to become entrepreneur. That's what I'm telling, right? So that's just Srikanth gave all this, thoughts. So you don't have to look for your job. You don't want to look for, you can define your own destiny. You can do everything. Srikanth is a successful entrepreneur. To tell him, right, to introduce him, I didn't do that deliberately. I can tell him that he's a successful entrepreneur. He ran a startup company which was acquired by a big company, right? Yeah, so he's a very successful entrepreneur, right? Not in terms of money, in terms of running a business. Don't look at, ask me how much value he sold his company. Right? No, that's not a question about debate, right? It's material, right? He built the skills, he built products, he built solutions, he built services. Then another company, he built skill set. He ran a business, right? And he's my junior in the college, right? We studied together, right? So he's able to come up to that, and we have similar experience, and so he's able to demonstrate that if he can do it. So there are 190 of you in this meeting. So each one of you can do it. Somebody wants to become an entrepreneur. You have the skill set. You said you have good knowledge of design. And it's a design both hardware and software design, system design, right? Productization, market needs, you understand everything. We'll help you to become an entrepreneur, right? We commit to help you, right? So I'll pause the presentation. I'm going to stop the sharing. We'll go to question and answer session. So if we have time, we'll come back to the presentation. Otherwise, we'll do one more session. So I'm opening the Q&A. So let me go one by one, and I'll ask my panelists to join. Microphone is disabled. Yes, that's a webinar mode. So if you want to talk something, you can send a message. It will enable you. If you cannot type a question, right? Let me know. Can you elaborate about Bharat Semiconductor Society? Mudan, are you there? Mudan, can you please unmute?
Yes, I'm here.
Can you answer about elaborate about Bharat Semiconductor Society? That's for you.
Okay, so Bharat Semiconductor Society was something which was certainly born about a year back. We are formally registered as a society based out of Chennai. The primary objectives that we started to look at the society was to see how do we fill the gap between the industry and the academia as such. So towards this, we basically are getting across ways and means of getting the academic to be able to come out and start offering courses which are relevant more towards the industry, like VLSI designs, the hardware system designs, embedded software, and as well as the ATMP or fab space product lines as such. So that way, the end students get benefited, the industry gets benefited by having experienced or people who are well thought out in this areas as such. So primarily, it's a society meant to look at bridging the gap between what the industry and the academia is currently looking at.
Thanks for that. Anyone, any other questions? We don't have any questions. Please ask. I'll stop the presentation for you to ask questions. If you want to talk, please send in Q&A. I'll enable you to talk. Okay. Okay, on the entrepreneur slide, given the lucrative salaries in industry, international consultancy is going to be seen as alternative career option? Srikanth?
Yeah, I
Answer?
think, see, I can quickly touch upon this. See, okay, first thing first is to actually reach this side. I actually was working in the industry for 49 till I was 45 plus years. So, I mean, the entrepreneurship does not always mean that you have to work long in the industry before you go into an entrepreneur. If you have a really good enough idea, you can definitely do it much more earlier in your life. Nothing prevents you from doing that. But what would help is if you understand what is the pain points in the industry, if you understand what are the positives that you have learned and where, is the value that you can add to a customer. So the point I'm trying to make is that, of course, in the initial part of the career, lucrative salaries and all of those do play a role. Depending on what is your own choices in terms of and what is also your own level of where you are in your learnings. If there is really a good enough idea, yes, there can be an entrepreneur, because there are many entrepreneurs who's as Bill Gates as well as Steve Jobs are all actually, they didn't even graduate before they started giving their company. So I'm not saying that we need to be like that, but the point really is that if you have a good enough business idea as an entrepreneur, you can do it at any point in time. Now, second thing is there's a question about salary here, which the industry does pays, and about how is this comparable to an entrepreneur. So these are two different paths, obviously. Say there is a difference, and as you get into active jobs, you will start realizing that the difference between an entrepreneur and a person who is working full-time to a corporate is that you will see differences in particularly the long-term valuation of the company, which will include if you are buying, if a company is being bought out after a certain stage and someone finds value in buying you out, then what results in is the valuation that you get is because a percentage of company you own, you will actually make a much bigger value of the pie. And that's one of the reasons why, people like, basically Reliance, owners and Ambani and all these guys are very rich. The reason is it's not that their salary is that much. It is because they own a part of the company. So to answer your question, right, if you have the skill set to really run your own business and have a good enough idea from where you can start a business, age is not a limitation at all. But at the same time, you have to have that idea which is so sought after by most people. So to answer the question, services companies, in fact, I work for a services company currently, and in fact, I ran a services company before it was bought by another services company, another services giant. So the services company is in fact a good way to start learning some things into your career rather than product companies, because as Hari was telling before, there are limited number of product companies, and Raman also made this point before in the call, saying that the expectation is pretty high. Services companies quite a few times actually help you to actually improve your knowledge so that you can eventually go into a product company as well. So what I'm saying is, I think, you should not at this point in be so choosy to look at what should be the right place to go, but worry about learning well. And the points that Hari was making, if you are good at what you do, then I think the other things take care of themselves. So, focus on studies, focus on what you want to learn and give the best for that, and find the best possible opportunity that you have. Frankly speaking, at the start of your career, you should not consider any opportunity as a bad opportunity to learn, because this is how you actually start. And this is very, very early times for all you guys. And anyone who is willing to give you some money and teaching you skill, you should be ready to take, rather than worry about, okay, I be picky about all these stuff. Okay. That's my quick answer.
Yeah, there's one more part to question, so let's answer it briefly. Please consider explaining the competition among various VLSI startup companies. And most of the companies end up as a service-based companies. Can you answer it like a high level?
Yeah, I can sort of say that this part is really true, because primarily speaking, the products in VLSI are pretty mature. So unless you find a real big change in, some underlying, thing, getting particularly in India, to be an independent product company in VLSI field is a challenge. Not many do exist. That is truth. However, that doesn't mean that you should not innovate. And there are still a lot of companies, particularly, AI ML areas are new areas. And, quite a few companies are, there in the US, which are starting out to that. And, even here, number of companies probably in non-VLSI areas has been very, very high in India. And I think, the VLSI is a small community by itself. And, there are quite a few that are starting out in some form. And most of those companies have probably been incorporated in the US, but then most of their engineering work from here. So to some extent, it's a question of time before these changes. Please do also realize that, VLSI as a field is probably 50 plus years in the US and Europe and other areas, whereas in India, it's probably less than maybe 20 to 25 plus years. So, it does take a gestation period for some of these more complicated skill sets to develop, and entrepreneurship by itself is also something that is new and taking roots more on the company space in India over the last maybe 10 years or so. Okay.
Thank you. Thank you.
Hi.
Hi. Next one, Murali. Murali, can you talk about what are problems faced by design engineer? I'm reading out so everyone knows. What are the problems faced by design engineer and interconnect of SOC?
Okay. Before getting into that, I just have some few points that I want to share. Okay. First is, I really want to thank Hari. He gave a very good landscape of the chip industry, semiconductor design, everything. So I feel like you guys are really fortunate to get this picture at a very early stage in your education. So we should all thank Hari to give us this presentation. That's the first thing. And second thing is just a kind of a picture to give you from a India perspective. Between 1995 to 2015, right? In those period, the software has gone from a startup kind of thing in India to a very matured level. Okay, but the semiconductor industry doesn't take off like that, but it was slowly taking off. But now with this mission of semiconductor in India, and people are thinking of moving some of the semiconductor company manufacturing things from Taiwan and things like that to India and US. That gives us a great opportunity for you people. So you are going to have a very best period in the next 10 years, I would say. From 2025 to 2035, it's going to be a golden period like what software industry has seen from 95 to 2015 kind of thing. So that is a big picture. And second thing is, I see lesser amount of electronics engineer are coming to the VLSI industry compared to they are going to the software industry. The one reason can be the number of openings and opportunity might be good. The second thing I see is they find it very difficult to get here because they find the electronics as a very difficult thing, and they are not learning that in an education perspective properly. So with these kind of training and extra interest you can put, you can definitely become a very good VLSI design engineer. The very fortunate thing in the current time is most of the thing what you are looking for, it is available in the YouTube as a videos, and many contents are available. I did graduated by 2000 from Trichy VLSI system. So that time we had very limited information about many of the things. But now you take anything, go to YouTube, you get most of that are given. So that is that perspective. Hari, coming back to your question, that seems to be a very difficult thing for me to say. But thing is, generally, there is a good level of system integration, not only from a software and hardware perspective, but there are other aspects to that which also have to be looked at. But when they come to a level of doing one level, they know what are the other interconnect adjacent things. Yeah, that's it from my side.
Okay, thank you, Murali.
Yeah.
So next question is for Raman. So please give some tips for engineer who's already working in a corporate, would like to grow in tech ladder as a digital design engineer.
Thanks. So who's already working as an engineer who wants to take care of what? Sorry. He wanted to grow as
You're already working in a company, but he wants to grow his tech ladder as a design engineer.
Oh, okay, very good. Yeah, I think guys nowadays, before I'm just telling 2 decades back, in US, right? In US, people have more technical jobs and technical competency, and a lot of jobs are started slowly moving to India. And in India, a majority of the, I think everybody, my colleague panelists, right? They all can agree. Everybody was going into a management ladder. Like they say, I want to be a manager after some 8 years, 10 years, right? But I think the complete change in paradigm now. I'm telling you very honestly. In fact, I can vouch you many examples from my colleagues and friends. If you're technical, you are more valuable and more not only valuable in terms of goodwill. It's also about compensation compared to you are in a management ladder. It is completely reversed, and in fact, I would say, for example, there is an engineer called principal engineer we call, who's a specialist, and equivalent is a director, and there is a senior principal and equivalent to senior director. Then fellow is equivalent to VP, vice president, right? If you look at the job opportunities, or if you look at the compensation, the fellow or the PEs or the principal engineers are getting higher than the directors. If sometimes I'll just give an example. In my team, I have 2-3 principal engineers and senior principal engineers. They're paid more than me, by the way. I'm not kidding. So if they are reporting to me, I'm the manager for them. But they are paid more than me, and I'm the one who's giving the stocks. Why I'm giving a technical guy more than my own salary, right? I'm just managing the project, but he is taking care of the real R&D or innovative or the leadership, right? So that is why I am willing to pay more than my own salary. The days are gone where you always say the managers are always getting higher salary than the direct reports. Is not this anymore. There are people. In fact, there is one guy who will be reporting to me is a fellow. He's above my level, by the way. But still, he's like equal to VP, but he reports to me. He's going to report to me in 2 minutes, few days. So, but I'm just letting you know that technical career is increasing in India much higher, and it's more valuable. Outside opportunities, especially for diversity engineers, I'm just telling you, women engineers, there was time when people take family as an important measure compared to career, and they usually, after some point of time, they just leave and go take care of the family. And women engineers are mostly impacted on that. But now, things are changing. A lot of women engineers are coming back and continuing as principal. In fact, there's a huge diversity talents coming in because there's an advantage. They are multitask, and as well as they want to give equality between a male or a female engineer. So I think that's also increasing. So that's why I say, guys, in fact, trust me, I myself moving. I mean, after some point of time, I moved twice in my career. I moved from management to technical, and then after some time, the management asked me to go and change it to management because they say we really want you to come back and manage this. So I have to change back to management, and in next year I might think I will move to technical completely because I feel that I need to do some more thing and learn. Opportunity is pretty high. So I believe, guys, do not get into this only if you're, unless otherwise you are so good in management, managing the project, managing the people, managing the ecosystem. Don't sign up for it. I mean, you go for the technical, and technical is the best value in India right now.
Right, and I just want to add one thing, Raman. This is a very, very good point because this is the case across most VLSI systems, setups as well. But I think the more crucial thing that people have to understand is, in fact, if people are worried about job safety, you are probably far more safer if you are more technical these days. Okay, and this is a fact. Again, by experience, I'm telling all these details, right? In the sense, we have seen cases where we actually have to trade a choice between a manager and a technical person. So I mean, technical ladder is absolutely crucial. India is realizing that, and there is definitely more onus on and big companies like where Raman was worked, Hari has worked, they are all, moving towards this for sure. So it's absolutely right what Raman is telling in this context.
Yes, I think this is, do not lose your grip on the technical. I'm just telling you guys, trust me, me, Srikanth, Hari and all, like a 25 years above, right? Like experience. After that, there is no difference between 25 and 26 or 28 or even 30 also, right? After 25 plus, that's it. But even now, I have been challenged my own leads, and I'm also my learning things newly in a technical aspect, like what are the, like that, right now if you look at the artificial intelligence, right, AI is going up, all the chat GPT comes, whether you guys know or not, I'm doing my coverage in the verification, I am using chat GPT in my coverage, the automation and anonymization myself. I'm just using that. I just introduced this concept now. My engineers are looking at how to enable this. But my point is that we as the leaders, either technical or management, also needs to be top on the technical stuff, because number of chips is going to be 4 times more than what you see now. I'm just trust me, because all the electric vehicles need chips. All your health and automations will become chips. All you wearables, whatever you, everybody will become wearable now, and everybody will have a phone in 6 billion to 7 billion phones and sooner. And then and all your automation in your home and the sensors and everything is going to be having chips. So VLSI is going to triple or 4 times grow, and all the AI you are talking about, the chat GPT, they all need servers. That means they need to work very fast processors, and all these processors are again the chips, right? So you'll see a lot of a software algorithm get into hardware, right? Because the speed is become very high, and that's where the chips are going to be increasing. So I believe I think the only caveat I'll tell you guys, those people who are already working in the corporate sector, that's good, but who are not working or who are going to start from college, trust me, you guys need to really pick up the Verilog and VLSI and System Verilog or whatever the training that you can get it outside or inside, wherever it is. Please go for it, because that's what you're all future going to be. And this, even though you're harder person, we are going to code everything in the language. We need to understand the concepts more, right? So, and one more thing I'd like to add. One of my student who's from VIT, he was mentioning he was from embedded systems. So I asked him, how did you learn all this Verilog and System Verilog? Because I did not teach him. I mean, I work for Intel, and I don't teach all. I don't have time to teach all these things. So he said, boss, I went to the Synopsys. They have a free compiler, or like a VCS, right? So they have a free version of that, and Cadence has a free version of Formal. They have, so there are a lot of student version of the tools. And he said, boss, I work on this, and I do it every day. Small thing. I made a compiler, I made a logic, and it's working now. So that's what I said. Hari was telling, right? Please be very passionate and go for it. I think it will going to give you. In fact, even though I don't have a right now, I cannot offer him a job for other reasons, but I'm sure that he will get a job, because he's already getting offers from outside companies because of his attitude and the passion, right? I think that's what it matters a lot. Hey, thanks, Hari, giving me opportunity. This is good.
Yeah. More than this, interesting question for you. Somebody from electrical officer working in Indian Navy, I don't know how many years of experience he mentioned, want to get into VLSI. What courses he has to do? Please take this question.
Probably I can take that, Rick.
Sure.
So I also wrote, the sky is not the limit. If he wants to join as an entrepreneur or I mean start some industry, definitely the goal has to be fixed. And then we can start small. Like if I give the example, today we need sensors everywhere. It's not just let's not call it just IoT, whether it's our mobile, our smartwatch, or anywhere, we need sensors everywhere. Even smart city projects, they need sensors. Now, if we see the scale, one may have a complete career out of just building the sensors, different types of sensors. And as new robots or the robotic industry comes alive in India, as well as the automotive industry is in the transitioning phase, they are going more and more driverless driving. They need lots and lots of sensors. So one can start to look into those particular areas and become successful. And then the courses, definitely system courses will help, like embedded systems programming, and specifically the VLSI design related courses, and Bharat Semiconductor can definitely help in bridging those things.
Thank you. So, Raman, I would like to take the next question. The student is asking, is turning in a digital design verification domain, and he wants some guidance on what skill set and concepts you need to learn to be a good DV.
Hari, I just lost in 1 minute at that. Link. You are asking.
Yeah, so
What you're
he is one intern is working on verification domain. He wants
Okay.
to build a good career. He wants to know what skill set and concepts you need to learn to become a good DV engineer.
Yeah, I'll tell you system Verilog, okay? UVM, system Verilog. These are the two concepts you go learn. There is a website called dvcon.org, and then UVM. There are 2-3 websites you just type at Google. I think they have a learning and some examples also they give, and join their groups, Google groups also they have. So these two are very important. And third point, I'll tell you guys, scripting. The guys in 8th grade from US or India, anywhere, any countries, 8th grade onwards, they started learning Python and Perl. Okay. And the scripting is very important for verification engineers because you have to automate a lot of things. So I would say scripting, UVM, system Verilog. These three are most important for you guys. And then that will help you from intern to full time to design engineer to the experts, right? So
Okay, thanks, Raman. Okay. So, Swapnil, this for you. Next student, he wants to know, he was initially interested in computer science field. He developed skills for it. So it's saying it's, I don't know what the question is. It's quite easy for me to use resources on the internet. I think it's an answer, it's not a question. But he's interested in core electronics, but it's very difficult to find sources and learn. Probably I'll answer it. I don't know what the question. Somebody anonymously asked. Yes. The first guy said something, but there are a lot of resources out there in electronics. So please connect with me. Sorry.
Yeah, hi, Hari, this is Bharat. So I can answer that.
Sure, yeah.
Yeah, for the core electronics, right? So I would advise to first go through the basic electronic circuits and digital electronics basics. So that covers the most of the stuffs in the core electronics part. And then later on, we can shift to the linear integrated circuit for the advanced level. So I think these 3 subjects should cover all the electronics related basics at least. So first, once you complete that, maybe you can try for an advanced electronics courses. That's a idea from my end.
Sure. Okay. Somebody wants to know some good concepts of Python and resources to use that in VLSI. Very good question. So who wants to answer that? Bharat, you want to take this question again on Python?
I will go.
Very sure.
So Vignesh, more than Python, a person should be focusing on learning the programming skills. Python is just a syntactical sugar. There are many different scripting languages out there. Recently, Python is very popular. Previously, Perl was super duper popular, and before Perl, TCL/TK was very popular scripting language. And then there are certain communities, because the tools were designed using certain programming language, and they want to just continue as they do not want to invest into additional development. So major thing is that a person should know the data structures and algorithm concepts better. And I would recommend to go through internet for one. There is one website called Rosetta Code. For a given problem, it lists the code for like some 10 or 50 programming languages. So for example, string manipulation, how it is done in C, C++, Java, Python, Perl, everything. I mean, you'll find everywhere. And once you know those basic things, basic operations to do, then you can apply those skills to the specific solution of a specific problem in VLSI. In general, unless and otherwise you know the programming concepts, the syntax, and the methodology as such properly, right solution may not come for any domain, just not limited to VLSI.
Okay. Yeah, next question was asking Visual Python for scripting, right? I think Vignesh, I think based on previous question, I understand your background in verification. So have you heard about CocoaDB? Python is used for verification. So UVM is kind of getting outdated. So CocoaDB is a Python-based verification. So Python is not only for scripting and automation, but can be used for writing test benches and verify, right? So there's a look for CocoaDB, but I'll go to post that in the answer that question and in the LinkedIn also. I'll answer that question. It is about CocoaDB, but there's a lot of Python scripting in our scripts available. You can just Google it out. There's a lot of YouTube resources. So you should be able to, there are a lot of textbooks available. So you'll be able to pick up that. So you don't have any prescribed resources. Just Google it out and pick up that. And if you don't know, yes, just please ping me in LinkedIn. I'll be able to help. Okay. So I think there is no more questions. Does anyone has any questions? Any student want to come onto the stage and talk something, please let me know. Just type in the chat window. Okay, so good question. I think let ask the panelists who want to take this question. After joining VLSI company, what are the challenges for freshers?
I will tell Hari. Because I just hired some 15 people, right, from interns to college graduates, right, conversions and all. So the biggest challenge I would say they are all having that academic thinking and where they take time and they don't think that quality is a very important concept. Like for example, whenever you do thoroughly, you do that and then make sure that you finish everything. And second problem is everything the academic guys think they always be available. Somebody's available to supervise them, right? But the actual reality is in corporate, very less percentage of monitoring or supervision is there, because everybody have their own job and they need to supervise. They take only 15% of their time to supervise you and mentor you. So the expectation is that you are on your own, but obviously they'll manage you. But some outcome of the quality of deliverables should be very high. So I think that is where we are having a tough time as employers, right? We are having a tough time. So if you're able to have every time you deliver something, you make sure the quality is top notch, and also make all your queries in a single document and probably send weekly reports or talk to the mentor. If you're allowing 1 hour, right, make sure that you utilize that 1 hour very efficiently and make sure all the questions are raised on that 1 hour and get it clarified. And that will be a very valuable for the mentor as well, for you also, right? So.
Okay. Raman, next question is for you. Very excellent question. I don't know, he's an anonymous guy. I want to personally thank him. How important to learn various protocols to start career as a design and verification engineer?
What is it? Again, you said about protocol. That's sometimes.
What are various? Yeah. How important is to learn various protocols?
I'll tell you, biggest protocols. Yeah. I think I'll tell you, there are. If the whole world is moving into two things called parallel interface and serial interface. Parallel interface is like PCI Express. You have the USB, SATA, UFS, Gigabit Ethernet, all those protocols. And serial these are serial interfaces. I'm sorry, these are all serial interfaces. What I said, the Gigabit Ethernet, USB, SATA, and all. Parallel interfaces are only memory right now. Memory and die-to-die connect like UCIe. There is a new protocol that is very famous right now. Everybody is working on that, and also DDR. DDR is extremely high valuable because memory, without memory, there is no processor exists. Okay, so I would recommend you guys work on a memory protocol which is DDR and PCI Express. these are the two first, I would say, priority one protocols you should learn. Because that's where the market is. Like a CXL again. CX is also a serial interface that that will be the next valuable. But I think if you don't know the basics, you cannot go. See, you cannot go to directly 12th grade, right? You need to go step by step. So that's why I said PCIe is the first one, and then similarly you start DDR probably, and then you move on to the next level. So that two protocols for both design and verification.
To answer in short, yes, it is important to know protocols. If you're verifying, you must know. Design, you have to know more. Verification guys need to know more, but design guys can know what they are designing. Only that part they can know. Verification guys should have more knowledge on the design.
Yes, absolutely. Verification is you need to break the design. That's called verification. Verification is not just checking whether your RTL is against suspect, right? You need to, that is a primary part of it, but secondary part of it is you need to break the design where your design is not working.
Yeah.
So these are the places where you have a problem, you have issues and it is not going to work. That's where the verification should be. And verification cannot do with them. So there is something called formal verification, functional verification. There is a coverage and emulation and prototyping. Many things are there. So it's a big concept there. So
there's an interesting question. Four college want to take. I answered him, but still we have time. I'd like to take that live. So most of the people in the panel are much experienced, and we got our own paths through which we came to respective positions. If you want to revisit your past and change some decisions, what are they in short? We all please give ideal path for a student willing to join VLSI.
See, I'll tell you my story, one line, and then I'll stop others to talk. See, I back in '97 when I graduated, that time the chip industry is very, very small. There were only TI and very small IBM, maybe small companies are there. Wipro was doing something. I really wanted to be VLSI, but I couldn't get a job. I was trying out and I got many software jobs, including Alcatel and many things. So one point of time, since I'm very interested in hardware, that is the right decision. I take it. I rejected the Belgium offer from Alcatel and joined IIT Madras as a project associate. The Belgium offer is almost 15 times or 100, maybe more times than the IIT used to give stipends, which is like 4,000 rupees. So that, I think a lot of people told me that was a bad decision because Belgium Alcatel was paying me in huge euros and a better life, but it's a software team. And but this IIT is a hardware job, but I think my passion goes well, and that's where I'm so happy that I made the right decision. Joining the VLSI and coming back right now, right? And almost 26 years back after. So I think guys, go with your passion. What do you really feel at heart? That's what you should do.
Okay. Any more questions, guys? 1 more minute. Sorry, I'll go back to my slides and cover 1 or 2 more slides. There's 1 more minute to go. So I'll let you go back to my slide. People are not asking questions.
Maybe I can append to what Raman says by the time you bring those slides.
Yeah, sure, I'll go to sure.
So for many students, when the career questions they are coming, so I started my career in some 3D VRML kind of things when I started back in 2000 plus years, and then later moved to the modern software development. I worked about 10 or 12 years in the pure software development and then became the software architect. And then I moved to the hardware side of it in my company. Now I'm taking care of the hardware performance aspects. So need to learn many deep technical aspects of the hardware design and implementation as well. So career path change is definitely possible if you have zeal for it, and sky is never the limit. Hari, back to you.
Yeah, okay. Yeah. So what are the skills needed, right? So this is basically soft skills when you talk about actually, right? What is technical skill and soft skills. So we're going to talk about the most important soft skills. Typically, they are not taught in colleges, or some colleges they teach. But it's not practical oriented, right? It teaches readers like more practical. So if you want to learn this thing, you have to do like more case studies, some team problem solving. That's how you learn the thing. You can't go to whiteboard and learn the soft skills, right? Do more by games and assign practical things, the case studies and group discussions, some problem statements. That's how you have to solve this and learn the skills. Attitude is very important, and that cannot be taught. That has to come within yourself. You should have the right attitude. You cannot say, oh, somebody's asked me to sign a bond. Oh, somebody's not giving me enough salary. No, it's not creeping, right? It's not acceptable. Just your point of view. So you should have the right attitude. If you give a job, if you want a job, I'll give a job. You have to take it up. So don't come and say, I'm not getting a job. I'm not getting a job in product companies. Don't say that. Attitude is very important, right? So I think this is the biggest problem what we have today, right? So I'll not work on verification. I'll not work on testing. Don't do that. That's the attitude problem. Employability skills. We are going to have a couple of slides on that. So soft skills, as I said, is important. Fundamental, foundational skills is the technical skills. That's extremely important. If you don't have that, whatever soft skills you have, it is not sufficient. We spoke about the technical skills in detail, like the last 1.5 hours, right? Job readiness skills, we are going to talk about in a moment. Multi-domain skills, we already spoke about it. I gave an example about doing a fight and all the example, medical instrumentation, everything. That is multi-domain skills, you must have them. Extremely important because you work with different teams in industry. The teamwork is very important. We'll talk about it, right? Expertise is very important, right? You have to be focused and build expertise. Don't say that I'm good in C, C++, Java, Verilog, UVM and SV also is added to the list now. I'm seeing a lot of people. I know I'm good in system Verilog. Can you get me a job? I saw a resume just before that meeting began also in LinkedIn. So sorry, we cannot help on job. It's as simple as that, right? So if your resume, you're saying your core skill is C++, Java and Python and Java, whatever it is written here, it will not fly. You have to differentiate. I'm going to have a slide to talk about differentiation, right? Extremely important. There are tons of resumes. There are millions of resumes. How, as an employer, how do we shorten the resume? There's no way, right? I'm not even able to read a resume for a second, right? So it's a problem what we have on the industry side, right? Analytical and problem solving is extremely important. You have to solve problems which are not happening in academics today. You have to build systems. You have to solve problems. You have to analyze. You should know how to debug. Debugging skills cannot be solved. You have to know how to debug your circuit or debug your software also, right? How to know how to debug the software, right? They're extremely important skills you need to develop, right? Teamwork is extremely important. Across the teams you have to work. You should know what they expect, what inputs you get, why timeliness is. Can I give 2 days late? What is the impact to my other friend in the other team, right? Quality of your work. So we call it as deliverables, and we call it as all this is extremely important. Your teamwork is extremely important. You have to understand other person's pain and help him to solve his problem, right? Just not doing your work is not enough. Teamwork is extremely crucial, important. So people are not exposed to kind of teamwork in the college, but you may do some of your clubs or some projects, you may be exposed to teamwork, but in syllabus doesn't teach about teamwork, right? Communication. Ask questions to my students. Ask any question. There's no stupid question, right? Ask question, asking for help, right? Communicate. If you have issues, you communicate. Send an email, pick up phone and talk. Communicate, right? So I'm going to share my LinkedIn details and email and everything. So I communicate. If you want to talk to me, send me an email. Connect me with LinkedIn and ask me. Or if you have an app, Slack app. So you go put a question in the Slack app. One of our mentors will come and answer you, right? So that is the most preferred way we prefer, right? That's why we announced it before this webinar, right? So that communication and asking for help is very important. Don't shy away from asking questions, asking for help. Asking for help is considered a positive attribute in industry. It's kind of taboo, right, in academics and in your personal lives, right? So asking for help is the most important skill. Okay, what skills that improve your employability, right? You want to employ it, and so you have to listen patiently. If somebody is telling, listen patiently without asking questions. Don't interrupt. Listen to the other person. Extremely important. Presenting skills. How do you make an impactful presentation? Right? You are seeing my presentation. Does it impact you? Right? I don't know. You have to give me a feedback. Right? So please send us a mail. The contact information is there in the end of the thing. Please connect with us and give us the feedback. Right? Problem solving. Right? So problem solving. How do you solve? We have been talking about problem solving. Extremely, extremely important. Right? So it's all very puzzle. Can you design a snake and ladder algorithm in a C code or in Verilog to design a solution for snake and ladder? We all know play snake and ladder and Ludo as a kids, right? Can you build a system to play a snake and ladder game? Right? Not a mobile. I don't need a mobile app. I want a hardware system, right? Hardware and software system. Can any one of you design a system? Raise your hand for solving snake and ladder and a Ludo kind of simple problems. Can you build a system to solve it? Right? Creativity, that's exactly extremely important. You have to be very creative. That's how you can differentiate yourself in others. Let's say 100 of you join in a company, and 2 years from now, only 5 of you or 10 of you will get promoted to the next level on a fast track, right? Your salary will be different. So that you have to be very creative. You have to solve problems in a different way. So that's what you get to be growing compared to your other friends who join at the same time. You have to be extremely creative. So you have to cultivate that habit, right? You have to think. Sky is the limit, right? So come up with finite solutions. You brainstorm, ask questions like how, what, when, how, right? Ask this question to yourself, right? So I'll just finish with this slide. We are running out of time. Staying positive. Don't get worried about I studied in COVID. The entire world went through COVID, and how it is a problem for you, right? We have lost, everyone we have lost near and dear. It's 3 years now. Cannot keep about COVID. It's all like past. We are all surviving today. We are all hale and healthy. Stay positive, right? Don't keep about recession. Look at positive of the recession, right? So look at stay positive. That's extremely important in your personal life and professional life, right? Aiming high. It's high, sky is the limit. Aim for the thing, right? Leadership, extremely important. Cultivate the leadership skills. You have to drive your friends, your team. Come, let's do this way. Let's do this. Leadership is not dominating, understand? Leadership is listening, leading from the technical skills, leading from the front, taking all the hit on you, don't pass it on to the team. That is the leadership skill, right? So have that skill. And teamwork, it's a teamwork, work as a team. You have to give up your egos, worry, listen to others, give and take, right? So that's extremely important. Teamwork is extremely important, right? So we'll just stop here. There are more slides. Few more slides. I'll set up a 1 hour session. We'll take more question answers. The next Saturday, Sunday we'll set up. I'll circulate the feedback form through the email and through the LinkedIn also. Please give us feedback so we can do more informative sessions to you. We all want to give it back. So I hereby thank all the panelists who attended the session. So thank you all the guys for your spending a valuable evening, weekend. You know, you have better things to do, but thanks a lot for helping the young minds. And all the young minds, please thank you again. I thank you from all the bottom of my heart for coming back into this and asking us to stay connected and asking questions, right? So please be connected with us. I'll send you the slides, whatever we have. We have a contact information. Please do connect with us. Use our Slack app, ask questions. We'll help you. We are here to help you. Don't think there's nobody to mentor you, right? So look for our emails and post in the LinkedIn. We'll share more details very soon, probably tomorrow. Okay. Thanks, everyone. Any parting ways from anybody, panelists? Sampath, any parting ways? Any parting comments? Any final thoughts? It seems no. Okay. Thanks everyone.
No, sir. No, sir. Thank you.
Thank you, everyone.
Thank you. Yeah.